Dear learners, in this unit we will introduce you to computer and its uses, capabilities and limitations of computers, classification of computers, types of computers, history and evolution of computers, basic operations of computers, and organization of computers. When you have completed this unit, you must be able to explain what is a computer, basic units of computer and their purpose, how computers work, features of computers, uses of computers, types of computers, generations of computers, applications of computers, and basic computer operations. Now we will discuss some characteristics of computers. Some features of computers are high speed, reliability, accuracy, large memory, logical decision-making, versatility, automation, and diligence. First feature of computer is its speed. The speed of personal computer is measured in terms of megahertz. That is, millions of clock cycles generated by microprocessor clock in 1 second. Most modern microcomputers are rated from 300 megahertz to 2 gigahertz. A typical 800 megahertz computer takes a very small fraction of a second to complete 1 cycle. Normally, several clock cycles are required to fetch a single instruction from memory, decode it, and execute it. The speed of workstations, mainframes, and high-speed personal computers is measured in terms of millions of instructions per second. These computers operate in the range of 20 to 1000 MIPS. Typically, a 100 MIPS computer can execute 100 million instructions per second. The speed of supercomputer is measured in terms of floating point operations per second. Floating point numbers include very small or very large numbers. Supercomputers operate at a speed of 500 gigaflops to 3 teraflops. A gigaflop is 1 billion flops and a teraflop. Now we will discuss some characteristics of computers. Some features of computers are high speed, reliability, accuracy, large memory, logical decision-making, versatility, automation, and diligence. First feature of computer is its speed. The speed of personal computer is measured in terms of megahertz. That is, millions of clock cycles generated by microprocessor clock in 1 second. Most modern microcomputers are rated from 300 megahertz to 2 gigahertz. A typical 800 megahertz computer takes a very small fraction of a second to complete 1 cycle. Normally, several clock cycles are required to fetch a single instruction from memory, decode it, and execute it. The speed of workstations, mainframes, and high-speed personal computers is measured in terms of millions of instructions per second. These computers operate in the range of 20 to 1000 MIPS. Typically, a 100 MIPS computer can execute 100 million instructions per second. The speed of supercomputer is measured in terms of floating point operations per second. Floating point numbers include very small or very large numbers. Supercomputers operate at a speed of 500 gigaflops to 3 teraflops. A gigaflop is 1 billion flops and a teraflop is equal to 1 trillion flops. Second and the most important feature of computer is reliability and accuracy. The results of computers are highly reliable and precise. Computers maintain accuracy within a millisecond, microsecond, nanosecond, picosecond, or any level of required precision. These are also accurate up to many decimal places in mathematical calculations. High accuracy and reliability is because a computer works on electrical pulses that rarely fail to convey correct information. The reliability of computers is maintained, especially in repetitive tasks. Further, the error-checking systems are built in the computer to reduce the chance of errors. Organizations provide backup computers that automatically take over in case the main computer fails. Recovery systems are implemented to further strengthen the reliability of data. Dear learners, another feature of computer is its large memory. Computer memory is used to store data and information temporarily or permanently. Temporary memory is normally referred to as random access memory. This is used to temporarily store programs that are currently executing on your system. The contents of RAM are erased when the power is off. Normally, the size of temporary memory is measured in terms of kilobytes and megabytes. Most modern computers and special graphics computers have large memories in multiples of gigabytes. Permanent memory is used to permanently store large repositories of data, user programs, applications like MS Office, and operating systems like MS Windows or Unix. An example of permanent storage is hard disk. The programs stored on permanent memory are available when you switch on the computer. Large amount of data can be stored on permanent storage devices. Computer memories have another advanced feature to dynamically access any data irrespective of its storage location. Apart from computations, a computer has the ability to take decisions. The computer has special circuits to perform logical operations. Logical operations include comparisons, such as a number is equal to, greater than, or less than another number. Depending upon the results of logical operations, a computer can take appropriate actions. Computer is also capable of comparing text, images, and even audio. The decision-making capabilities of computer has led to the invention of artificial intelligent machines. Computer is a versatile machine. It is capable of solving a variety of problems. The use of personal computers have considerably grown in the fields of communications, multimedia, scientific research, designing, engineering, education, and entertainment. Another remarkable feature of computers is its ability to perform operations automatically. When the computer is switched on, it automatically executes instructions to check all peripheral devices, loads the operating system, and provides interface to the user without human interaction. Computer is a diligent machine. It never feels tiredness. You can complete different jobs or a single task repeatedly without losing precision. Some computer systems are rarely down in several years. These can process data continuously and accurately. Dear learners, although computers are widely used due to their versatility, but computers have certain limitations. Some limitations of computers are lack of intelligence, need of proper environment for smooth operation, and need of special language. The first limitation of computer is its lack of intelligence. Although a computer can perform logical operations at a very fast speed, but it is unable to think like a human. Presently, computers cannot tell the fragrance of a flower or have no aesthetic sense. Computers need proper environment for smooth operations. These can only operate in dust-free environment under certain temperature conditions. Computers can only understand binary codes, that is zeros, ones, and their combinations. These codes are not commonly used by humans. Special software interpreters and compilers are used to convert natural languages to computer understandable codes. Despite these limitations, the popularity and applications of computers are considerably growing. Dear learners, the quest for a mechanical servant that could free people from tedious aspects of thinking is centuries old. It started with the introduction of abacus some 5,000 years ago. Abacus is considered the original manual counting device. It is still used in education to demonstrate the principles of arithmetic. This device contains beads on rods. Calculations are made by positioning the beads upward or downward. Dear learners, now we will discuss the contributions of scientists, professionals, and students who contributed to bring to us this marvel of the modern age. In 1642, French mathematician and philosopher Blaise Pascal invented Pascaline. It used wheels like telephone dials. Numbers were arranged on these dials. Wheels were revolved to make calculations. In 1801, a French weaver named Joseph-Marie Jacquard created Jacquard loom. Punched cards were used to direct the movement of needles, thread, and fabric to create different patterns in a fabric on a loom known as jacquard weaves. Efforts were made by different scientists across the world, and in 1842 Charles Babbage introduced difference engine and then an analytical engine. It was a general-purpose computer that could add, subtract, divide, and multiply in automatic sequence. Its average speed was 60 additions per second. The idea of Babbage was further refined and improved by Lady Ada Augusta Lovelace. She proposed that punched cards could be used to instruct Babbage's engine to perform repetitive tasks. Due to her valuable contributions, she is considered as the first programmer. During 1890, Dr. Herman Hollerith developed the first electromechanical punch card tabulating machine. Hand punch was used to enter data into cards. A sorter box was used to read and sort these cards. The output was summarized on tabulating dials. Hollerith earned handsome income by leasing his machinery to the governments of the USA, Canada, Austria, and others. His invention led to the concept of modern data processing. Hollerith is also the founder of Tabulating Machine Company that later on became IBM. Dear learners, sophisticated punch card devices were introduced from 1920 to 1950. The electromechanical accounting machine family included card punch, verifier, reproducer, summary punch, interpreter, sorter, collator, and accounting machines. These machines were very large, heavy, and required physical labor to operate. The first modern digital computer, a Tanasoff Berry computer, was built in Iowa State University campus between 1939 and 1942. The development team was led by John Atanasoff, professor of physics and mathematics, and a graduate student, Clifford Berry. This machine included many features like binary arithmetic, parallel processing, storage, and computer functions. It weighed about 750 pounds and could store about 3,000 bits of data. In the early 40s, the first electromechanical computer, Mark I, was developed by Harvard University professor Howard Aiken. Dear learners, sophisticated punch card devices were introduced from 1920 to 1950. The electromechanical accounting machine family included card punch, verifier, reproducer, summary punch, interpreter, sorter, collator, and accounting machines. These machines were very large, heavy, and required physical labor to operate. The first modern digital computer, a Tanasoff Berry computer, was built in Iowa State University campus between 1939 and 1942. The development team was led by John Atanasoff, professor of physics and mathematics, and a graduate student, Clifford Berry. This machine included many features like binary arithmetic, parallel processing, storage, and computer functions. It weighed about 750 pounds and could store about 3,000 bits of data. In the early 40s, the first electromechanical computer, Mark I, was developed by Harvard University professor Howard Aiken. IBM sponsored the development of this huge machine. In 1946, first large-scale digital computer, the Electronic Numerical Integrator and Computer, was developed. This was developed by John Mauchly and John Presper Eckert, an engineer at Moore School of Electrical Engineering in the University of Pennsylvania. ENIAC was used to prepare firing and bombing tables for the U.S. Army and Navy. It was also used in secret research that was aimed at building powerful and destructive bombs. ENIAC consisted of 30 separate units, power supply and air cooling system. It weighed 30 tons, used 19,000 vacuum tubes, 1,500 relays, and hundreds of thousands of resistors, capacitors, and inductors. It required a large amount of electricity. It could perform 5,000 additions per minute and hundreds of multiplications per minute. Another important digital computer in history was Colossus I. It was built at a secret government research establishment in England under the direction of Professor Max Neumann. It was designed to break German Enigma codes during World War II. It could scan and analyze 5,000 characters per second. Colossus became operational in December 1943 and proved to be one of the most important technological aids to victory in World War II. In 1949, EDSAC was introduced. This was capable of storing computer program. In 1950, EDWAC was developed. It could store instructions Hopper conceived the idea of COBOL programming language. It was a general-purpose English-like programming language that is still used by many organizations. Dr. Grace developed a compiler that translated programs written in COBOL to run on a variety of computers. She is also the pioneer to find first real bug in a computer. Programmers debug softwares to find out errors or bugs in their programs. Second-generation computers were introduced during 1959. These were built by using transistors instead of vacuum tubes. These computers were more powerful, reliable, less expensive, and smaller in size than their predecessors. Until early 60s, only large companies were producing mainframe computers. In 1963, DEC introduced PDP-8. It was a transistor-based mini-computer. The demand for small computers tremendously increased for business and scientific applications, and by 1970, a number of firms were manufacturing computers. Dear learners, technology was rapidly changing and third-generation computers were introduced during 1964. These computers used large-scale integrated circuits. IBM developed System 360 with the idea of upward compatibility that allowed companies to upgrade their computer systems without converting their data. Besides developments in hardware technology, scientists were busy in developing the techniques to interact with the computer to perform a variety of tasks. In 1960, Dr. Thomas Kurtz and Dr. Johann Kamini started developing a programming language and introduced Basic Programming Language in 1964. It became a popular programming language for business and scientific applications. BASIC was supported on many types of computers. During 1971, fourth-generation computers were introduced with the introduction of integrated circuit. This was significant innovation in the history of computing. During early 70s, Bill Gates and Paul Allen were busy in developing games for personal computers and introduced a basic programming language. They formed today's most influential software firm, Microsoft Corporation. It revolutionized the idea of personal computing with the introduction of Microsoft Disk Operating System. Dear learners, personal computers were not available. Apple II personal computer was introduced in 1975. This was a prominent venture by Stephen Jobs and Steve Wozniak. In 1981, IBM introduced IBM Personal Computer, and many personal computers were sold by the end of 1982. At that time, many other companies started manufacturing of IBM PC compatibles. The use of personal computers had considerably increased in business. There was a tremendous need for business software. Mitchell Kapoor established Lotus Development Company. Lotus Corporation introduced electronic spreadsheet application that boosted the sales of IBM PC and Lotus 123. Dear learners, the credit for today's friendly, easy-to-use, point-and-click graphical user interface goes to Apple Computer. GUI changed the human-computer interaction from text-based exchange mode to friendly WIMP interface. During the last 2 decades, Unix, Microsoft Windows, Sun Solaris, Apple Macintosh, and many other graphical user interface operating systems were introduced. Dear learners, during the last few years, there has been a tremendous advancement in microprocessor technology, and now personal computers operate at speeds up to 2 GHz. There has been a considerable advancement in computer peripheral devices. Most powerful supercomputers, mainframes and minis based on RISC and CISC computing technologies are available at speeds beyond imagination. Dear learners, by the time you finish this course, you may visualize drastic changes in computing technology around you. Dear learners, in this unit we will introduce you to computer bus and its types, serial and parallel ports, operating systems for personal computers, microprocessor and its characteristics. After completing this unit, you should be able to define computer bus, define different types of buses and their features, understand the use of different ports, explain different PC platforms, explain word size, cache memory, RISC computing, CISC computing and parallel processing. Dear learners, the computer bus is an electrical path between the components of a computer. It consists of around 40 to 150 electric wires running parallel to each other. There are 2 types of computer buses, known as the internal bus and external bus. The internal bus connects the CPU and other devices on the motherboard. The external bus is used to connect input-output devices to the CPU. It has 2 parts that are data bus and address bus. The data bus is used to carry data between CPU, memory, and other hardware devices on the motherboard. These can transfer 8, 16, 32 or 64 bits of data in a unit of time. The address bus connects CPU and RAM and carries only memory addresses. Dear learners, the computer motherboard has many expansion slots. These allow you to enhance the processing functionality by adding expansion boards. A number of new bus standards have been introduced with the advancement in microprocessor technology. These include ISA bus, local bus, PCI bus, AGP bus, SCSI bus, and USB bus. The most common expansion boards are plugged into an industry-standard architecture expansion bus. It was introduced in the mid-80s and is still used to attach slower devices like disks, modem, and input devices. Local bus technology is used to attach faster devices to the CPU. It runs between components on the motherboard. Dear learners, Peripheral Component Interconnect Bus was introduced by Intel. It improves the performance of high-speed peripherals for graphics operations and high resolution. It makes it easier to integrate audio, video and graphics. PCI buses can transfer data up to 133 megabytes per second. Accelerated graphics bus allows the video card to directly access system RAM. It greatly increases the speed of graphics performance. AGP standard has led to the development of accelerated video cards that support 3D motion videos. AGP buses are rated at speeds in the range from millions of bytes per second to billions of bytes per second. SCSI standard was introduced to overcome the limited number of expansion slots on the motherboard. It extends the bus outside the computer by a cable that allows you to plug multiple devices into a single port. This process is called daisy chaining. Different SCSI standards have been introduced. The emerging standard is SCSI 3 that allows you to link up to 127 devices. The newest Ultra 3 SCSI standard supports 32-bit bus and can transfer data at a speed of up to 160 megabits per second. Another most modern bus standard introduced by Compaq, Microsoft, IBM, and other industry leaders is Universal Serial Bus. Some features of USB are to eliminate the need for installing separate expansion cards, plug and play feature. It allows to daisy chain up to 127 USB compliant devices to a single USB port. It allows fast data transfer rates up to 12 megabits per second. Dear learners, external devices including keyboard, mouse, monitor and printer are connected to the computer by using different ports. There are two types of communication ports that are parallel port and serial port. Parallel port allows parallel transmission of data. It consists of 8 or more wires for data transmission. It uses 25-pin or 36-pin connector. The data travels in parallel over 8 lines. The extra lines carry control signals. Parallel port provides interface for magnetic tape, other computers and high-speed printers. Serial port allows a single bit of data to be transmitted at a time. It uses 9-pin or 25-pin male or female connector. One line carries serial signal to the device and another line carries signal from the device. Other lines carry control signals. Usually the mouse is connected with the serial port. Several other ports are available on the back of the computer to plug different devices. These include SCSI ports, USB port, dedicated keyboard port, dedicated mouse port, and infrared port. SCSI port enables faster data transfer and many devices can be attached to a single SCSI port. USB port offers plug and play feature. It is a high-speed port that allows up to 127 peripheral devices to be connected to a single USB port. Dedicated keyboard serial port has 5-pin or 7-pin round connector for the keyboard. Modern motherboards also support dedicated serial port for the mouse. IRDA port or infrared port can transmit data by using infrared light waves. It works within a few feet distance. Dear learners, a PC platform is a standard for which different types of software are developed. Typically, a platform has two key elements, that are the processor and the operating system. The operating system is designed to run on a single platform or, in some cases, on a multi-platform. In cases of multi-platform, the computer runs its native platform and emulates other platforms. Before selecting the platform, it is important to ensure the availability of all required application software and compatibility of the platform with existing hardware, software and expertise. A number of platforms have evolved during the past few years. The first element of PC platform, that is the processor, will be discussed in detail when we talk about microprocessors later in this unit. We briefly discuss operating systems in their chronological order. The first and most powerful operating system is Unix. It was introduced in the early 70s by Bell Labs. Unix was distributed by Bell Labs for teaching and research purposes. This led to development of a number of Unix-based software. These include AUX for Apple Macintosh computers, AIX for IBM workstations, Solaris for Sun Microsystem, OpenVMS for Apple workstations, SCO Unix and Xenix. Older versions of Unix provided text-based interface, but now more sophisticated. Dear learners, the second Macintosh operating system had many features. The second PC platform that ruled the world of computers for the last 15 years is Microsoft Disk Operating System. It was easy to use operating system for IBM PC-AT and compatible computers. DOS became inadequate for powerful computing with the advancement in microprocessor technology. These are some limitations of DOS. It was designed for 8-bit and 16-bit microprocessors. It could not avail the advantages of 32-bit architecture introduced in modern microprocessors. It could execute only a single application at a time. It supported only one user and single processor. Another critical limitation of DOS was its inability to access larger RAM. It could only recognize 640 kilobytes of RAM. Additional software was required to access memory beyond this limit. The file name in DOS has certain limitations. DOS provides command line interface. User started switching to other operating systems with the introduction of GUI by Apple computers. Dear learners, the Apple family of the second PC platform that ruled the world of computers. Macintosh operating system had many features like similarity of applications, built-in network support, plug-and-play support, sharing across different applications. Although Mac operating system works only on Macintosh computers and compatible hardware, it is still the first choice of many users. Realizing the popularity of GUI, Microsoft introduced Windows in the mid-80s. It executed with the support of DOS. Windows replaced the command prompt mode of DOS with point-and-click graphical user interface. Windows was not a complete operating system, but an operating environment. Later on, Microsoft released Windows 3.0, 3.1 and Windows for Workgroups. These were stable software and capable of loading more than one program at a time. OS/2 was another PC platform operating system. It was introduced in 1982 after the introduction of 80-286 microprocessor. OS/2 was a joint venture of IBM and Microsoft. It was GUI-based multi-user and multitasking operating system. It had support for networking. Microsoft switched to develop its own products, but IBM still continues the development of OS/2. In the early 90s, Microsoft released Windows NT for powerful workstations and network servers. It was a 32-bit operating system. Since the network computers fall into two categories, Microsoft released two products that are Windows NT Workstation and Windows NT Server. The main features of Windows NT are: it runs on a large number of systems that use Intel, AMD, Cyrix or other RISC-based processors. NT-based workstations support peer-to-peer networking. It supports both FAT and NTFS file system. It provides disk mirroring features that allow backup hard disks to take over in case the primary hard disk fails. Windows NT Server is another operating system. It runs on server-side computers. It has similar look and feel like Windows NT. It has the features like file and print server, allows better security features for grouping and authenticating users, controlled access to network resources, disk duplexing and disk mirroring, combined storage on different disks to look and function as a single disk. Microsoft released Windows NT Server is another operating system. Dear learners, a microprocessor is a small silicon chip made up of a number of transistors and integrated circuits which work together to process information at an incredible speed. A microprocessor, or CPU, is sometimes called the brain of a computer. The CPU comprises of two main components. These are control unit and arithmetic logic unit. Control unit reads and interprets instructions from main memory, directs the operations of processor components, and controls the flow of data in and out of memory. Arithmetic and logic unit performs all the arithmetic and logic operations. Arithmetic operations include addition, subtraction, multiplication, and division. Logical operations include comparing numeric and alphanumeric data. Performance of a processor depends on a number of features which are word size, number of registers, bus speed, addressable memory, cache memory, clock speed, and math coprocessor. The first feature of microprocessor is word size. It is referred to the size of CPU register. It describes the number of bits that the processor can process in a unit of time. A processor can process large amount of data if the word size is larger. Typically, processors have 16, 32 and 64 bits word size. This graph compares different processors. Modern microprocessors contain high-speed storage locations called registers. These are used to hold data, instructions, and results of operations temporarily. These registers include general-purpose arithmetic and logic registers, flag registers, stack registers, segment registers, and index registers. This table shows some details. Next feature of computer is its bus speed. Computers use data bus to transfer data between components of CPU and address bus to transfer addresses between RAM and CPU. Processors have 16, 32 or 64-bit buses. These operate at 66, 100, 133, 200 or up to 400 MHz. The next feature of microprocessor is its addressable memory. The figure shows a comparison between processor addressable memories. Modern microprocessors contain high-speed storage called cache memory. Cache stores the data and instructions that are accessed by the processor repeatedly. Microprocessors have support for level 1, level 2 and now level 3 cache memories. Level 1 cache is built inside the microprocessor. Earlier, CPUs supported 0.5, 8, 16 and 32 kilobyte cache memories. Modern microprocessors contain up to 256 kilobytes of level 1 cache. Level 2 cache is external to the microprocessor. It lies between the microprocessor and RAM on the motherboard. Its size varies from 512 kilobytes to 2 megabytes. Some processor manufacturers have introduced level 3 cache. The next feature of the microprocessor is its clock speed. Higher the clock speed, faster is the processor. Modern microprocessors have clock speeds up to 2 GHz. These are capable of executing up to 2 billions of instructions per second. Microprocessors contain millions of transistors to function at a high speed. This graph compares the number of transistors present in different microprocessors. Microprocessors have become number crunchers and can process very large or very small numbers accurately. For this purpose, microprocessors have support of number coprocessors, math coprocessors and floating point processors. For example, Apple PC family G4 processor is capable of performing billions of floating point operations per second. Two processing techniques greatly affect the speed of processor. These are CISC and RISC. CISC-based processors can execute 200 to 300 instructions. Intel and Motorola processors are CISC-based. Apple family of processors are RISC-based. The RISC theory states that if the instruction set is kept small, each instruction will execute in less time. Another concept of processing is parallel processing that allows multiple processors to share the workload. Although the idea of parallel processing is not new to minicomputer, mainframes and supercomputers, these days it is implemented in personal computing. The introduction of dual and quad processing has increased the computing power of today's personal computers. Dear learners, in this unit we will discuss number systems, representation of numeric and alphanumeric expressions in number systems, conversions from one number system to another number system, basics of Boolean algebra, Boolean expressions, precedence and associativity of logical operators, truth tables of Boolean expressions, logical operations and their physical representation as logical gates. Dear learners, after completing this unit, you should be able to understand number systems, represent numeric and alphanumeric expressions in number systems, convert a whole and fractional number from one number system to another number system, solve Boolean expressions, understand precedence and associativity of logical operators, create truth tables, solve and interpret truth tables, and understand the purpose of logical gates. Dear learners, number systems are used to represent numeric values in different ways. The four number systems are decimal, binary, octal, and hexadecimal number system. The first and most commonly used number system is decimal number system. It consists of 10 symbols or digits. The total number of symbols in a number system is known as the base of that number system. Since there are 10 symbols in decimal number system, its base is 10. Each of these symbol or combination of symbols represents a numeric value. Decimal system is a positional system, and each number is represented in the powers of its base. For example, in the number 528, 8 is at unit position and represented by the symbol multiplied by base of the system raised to power 0. 2 is at 10th position and represented by the symbol multiplied by the base of the system raised to power 1. 5 is at 100th position and represented by the symbol multiplied by the base of the system raised to power 2. Decimal number is represented like this. Here 10 is the base of decimal number. The second number system is binary number system. Although this is not commonly used by humans, this is the only number system used by computers. It has two symbols. These are 0 and 1. Combination of these symbols can represent numeric and alphanumeric data. Encoding systems like ASCII, EBCDIC, ANSI, and Unicode are used to represent numeric and alphanumeric data in binary number format. This table shows some symbols and their ASCII equivalents. Third number system in our discussion is octal number system. As its name implies, it has 8 symbols. These are 0, 1, 2, 3, 4, 5, 6, and 7. An octal number comprises of only these symbols. Here is a valid octal number and invalid octal number. Octal number system is represented like this. Here, 8 represents the base of octal number. Octal number system is also a positional system, and each symbol determines its value in power of 8. The octal number 735 is equal to 477 of decimal number. This table shows binary equivalents of octal numbers. This table can be referred when you are converting an octal number to its binary equivalent. The last number system in our discussion is hexadecimal number system. There are 16 symbols in this system. The symbols from 0 to 9 represent their numeric values, and the alphabets A, B, C, D, E, and F represent values 10, 11, 12, 13, 14, and 15. Hexadecimal numbers can represent very large numbers. These are used to represent memory addresses. Dear learners, computers can only understand binary numbers. The numeric and alphanumeric expressions need to be converted to binary numbers before processing. The results are then converted back to required expression. It is important to understand the conversion process. This method illustrates the conversion of a decimal number to its binary, octal, or hexadecimal equivalent. The 3 steps to complete this conversion are: divide decimal number by the base of desired number system. Repeat this method until quotient is less than the base. The bottom-up sequence of remainders will be the converted number. To convert the decimal fraction, multiply it with the base of required number system. Repeat this process with fractional part only until fractional part becomes 0 or up to the required precision. The results of whole number and fractional part are then added to obtain the desired number. Decimal point is placed in the same position in the required number as it is present in the decimal number. You can use place value method to convert other number systems to decimal number. The steps to perform this conversion are: multiply the symbols with their base raised to powers in ascending order from right to left. The calculation will give the result. The procedure to convert whole number to decimal number is same as discussed in converting other number system to decimal number. To convert the fractional part, divide each symbol of the fraction with the base of number system raised to power starting from 1 in ascending order from left to right. Dear learners, now we will discuss logical gates. The physical representations of logical operations are called logical gates. These are based on the results of logical operations. Different types of logical gates include or, and, not, complemented and, complemented or, exclusive or, and equivalence gate. Now let us discuss each logical gate in detail. The first logical gate in our discussion is logical OR gate. It is physical realization of logical or operation. The physical representation of OR gate for 2 and 3 inputs is given here. Here is truth table for logical OR gate. The plus sign represents logical addition. It is important to note that the result of logical OR is 0 when all input values are 0. AND gate is physical representation of logical AND operation. It is drawn like this. It takes at least 2 input signals. This truth table represents AND operation for 3 input variables. It is important to note that the result of logical AND is true when all input variables are true. NOT gate inverts the value of input variable. The input is inverted when it is passed through the logical NOT gate. Physical representation of NOT gate is like this. If input is 0, the output is 1, and if input is 1, the output is 0. Complemented AND gate is represented by the equation A bar plus B bar. The truth table for complemented AND gate is represented like this. The input variables are complemented and logical addition is applied to get the result. The result of complemented AND gate is 0 or false only when both input variables have binary values 1 or true. The result of complemented OR gate is equal to OR gate with an inverter. It is represented by the equation A bar dot B bar. Different physical representations of complemented OR gate are shown here. The truth table for complemented OR gate is represented for 2 variables like this. The input variables are complemented and logical multiplication is performed to get the result. The result of complemented OR gate is 1 or true only when both input variables have binary values 0 or false. Dear learners, Boolean algebra was introduced by George Boole. The symbolic notations of Boolean algebra are analogous to electronic switches. The electronic switch represents 0 when the switch is open and 1 when the switch is closed or off. These values are represented by false and true in Boolean algebra. The expressions of Boolean algebra help to design electronic switches and gates. The electronic switches are considered operands, not and or are operators. These are physically represented by logical gates. The operands take input in 2 states, that is, on or off. That is analogous to binary number system. The on-off state or sequence of on-off states are interpreted in binary number sequence. Dear learners, now we will discuss basic logical operations of Boolean algebra. These operations are used in conditional programming. These are discussed in the order of precedence. The first logical operation in our discussion is complement or logical negation. It is a unary operation and applied to a single operand. The complement value of 1 is 0 and complement of 0 is 1. When negation is applied on input, it negates its value. Let us see a simple example. Let A be input symbol and A bar be complement of A. If A contains 0, its complement will contain 1. The result of double complement is original value. Double complement is represented by double bar. The second logical operation is logical multiplication. AND operator is used for this operation. It is a binary operation and takes two variables. AND operation is represented by a dot. The result of logical multiplication is a logical value. This table shows two input variables and the result of logical multiplication. 4 rows show different input and their relevant output. It is important to note that if any of the input variables has a value 0, then the result will be 0 or false. The result will be 1 or true only if both the input variables are true. The third logical operation is logical addition. This truth table shows the results of logical addition. 4 rows show different input and their relevant output. It is important to note that the result of logical addition will be 0 or false if both input variables are 0. The result of logical addition will be 1 or true if any one of the input variables is true.
Dear learners, in this unit, we will introduce you to data processing techniques, data storage and their features, types of computer memory, primary and secondary storage devices, input devices, output devices, and special terminals.
After completing this unit, you should be able to explain data processing techniques, data storage devices and their features, types of computer memory, commonly used input and output devices.
Processing methods are used to process different types of data. Conventionally, batch processing, online processing, and real-time processing techniques are used. Batch processing method is also known as sequential, offline, or stacked processing. In this method, jobs are received and placed in a stack or queue. These jobs are entered in a system after a specified interval of time to generate output. Batch systems are used where information is required after a specified interval of time. In online processing method, terminals are used to enter data to a host computer to generate the useful output. Modern computing has introduced the concept of web-based online processing system. For example, the air reservation system is an online system. Real-time systems accept and process data simultaneously. There is no time delay in real-time systems. For example, the radar system and weather forecasting system are real-time systems. Processing methods are used to process different types of data. Conventionally, batch processing, online processing, and real-time processing techniques are used. Batch processing method is also known as sequential, offline, or stacked processing. In this method, jobs are received and placed in a stack or queue. These jobs are entered in a system after a specified interval of time to generate output. Batch systems are used where information is required after a specified interval of time. In online processing method, terminals are used to enter data to a host computer to generate the useful output. Modern computing has introduced the concept of web-based online processing system. For example, the air reservation system is an online system. Real-time systems accept and process data simultaneously. There is no time delay in real-time systems. For example, the radar system and weather forecasting system are real-time systems. In modern computing environments, large amount of data is to be processed. A large number of applications are required to process these data. Data processing techniques are now supported by state-of-the-art PC platforms. Modern operating systems execute applications in multi-programming, multitasking, and time-sharing environments.
Dear learners, different measurement units are used to measure storage capacity. In computers, the measurement units are bit, byte, kilobyte, megabyte, gigabyte, and terabyte. The smallest unit of data representation is bit. It is acronym for binary digit. It is either 0 or 1. A 0 represents an off bit and 1 represents an on bit. Combination of 8 bits is called a byte. You can use different combinations of bits to represent alphabets, numbers, special characters, and other symbols. 8 bits can be used to represent 256 different symbols. The next storage unit is kilobyte. In general, kilo means 1000, but in computers it is equivalent to 1024 bytes. Megabyte means roughly 1 million bytes. Exactly, it is equivalent to 1024 kilobytes. A gigabyte is roughly equal to 1 billion bytes. Exactly, it is equivalent to 1024 megabytes. Gigabyte storage can store enormous amount of data. A terabyte is equivalent to 1024 gigabytes. Terabyte is a huge storage capacity, and it can store hundreds of thousands of printed pages and information that may require thousands of CDs and DVDs. Dear learners, RAM stands for Random Access Memory. It is also called volatile memory, primary memory, or temporary memory. Its purpose is to hold data, results of operations and programs temporarily. The contents of RAM are lost when the computer is turned off. RAM is a very fast memory as compared to permanent memory. Over the past few years, different types of RAM have been introduced. These include RAM, SRAM, SDRAM, RDRAM, VRAM and SGRAM. ROM stands for read-only memory. It can store programs like RAM with two major differences. First, ROM is read-only memory and its contents cannot be changed. Second, the programs stored on ROM are available even if the computer is turned off. The programs stored on ROM chips are called Basic Input-Output Services. These programs communicate with computer devices like RAM, keyboard, monitor, and other devices. Modern microprocessors contain high-speed storage called cache memory. Cache stores the data and instructions that are accessed by the processor repeatedly. Microprocessors have support for Level 1, Level 2, and now Level 3 cache memories. Secondary storage is also referred to as permanent storage, auxiliary storage, external storage, or backup storage. Secondary storage devices are used to hold data, useful information, and computer software. Modern storage devices include both magnetic and optical devices. Magnetic devices include floppy diskettes, hard disks, magnetic tapes, and cartridges. Optical devices include recordable CDs, rewritable CDs, and DVDs. Some portable devices have recently been introduced. These include zip drives and thumb drives. These can hold large amount of data.
Computer uses input devices to enter data to the computer system. Commonly used input devices include keyboard, mouse, scanner, cameras, pens, touchscreen, game controllers, optical input devices, and multimedia input devices. All these are discussed in this learning session. The most commonly used input device is keyboard. Keyboards differ in size, shape, and a few special purpose keys. All keyboards contain alphanumeric keys, modifier keys, numeric keys, cursor movement keys, function keys, and special keys. The arrangement of alphanumeric keys is known as QWERTY layout, and most keyboards are designed with this layout. Another type of keyboard layout is Dvorak. It places the most commonly used keys in the middle row.
Now we will discuss different keys and their functions. The escape key is used to cancel any action or dialog box in Windows environment. The tab key allows you to move to the next tab position while you are typing in a word processor. The enter key is used to execute the selected application or the menu item. It also allows you to finalize the dialog boxes with OK or cancel button. The backspace key allows you to erase one character that was just typed. When caps lock key is turned on, it allows you to type capital letters. When it is turned off, you can type small letters. Modifier keys are used to modify the input of other keys. For example, you can press the Shift key and then press the numeric key 4 in the top row of alphanumeric keypad to print a $sign. You can hold the Control key and use the mouse to right-click and select multiple files. You can hold the Control key and press A to select all the text in a Word file. You can use Control, Alt and Delete keys to access the Windows Security dialog box. Numeric keypad is used to enter numbers to the computer system. When numlock is turned off, it allows cursor movement. Cursor movement keys are available on the standard keyboards. IBM-compatible keyboards contain special keys to access the Start menu and the Properties menu. Function keys are used for special functions. For example, the F1 key is used to load help in most softwares. The F2 key allows you to edit current cell contents in Microsoft Excel.
A trackball is also a pointing device. You can roll the ball in the place and move the pointer on the screen. This diagram shows different shapes of trackballs. Trackpad is another point-and-click device, usually available on the laptops and notebooks. It senses the finger touch and allows moving the pointer along the movement of finger. Trackpads have 2 or 3 buttons similar to mouse. Some trackpads sense the hit of your fingertip. Modern laptop computers have a track point between the alphabetic keys. Pushing the track point forward, back, left or right controls the pointer. Buttons are provided to select the options. Pen-based systems allow the user to point, draw and write with a special pen on computer screen. Another input device is touch screen that allows the user to place a fingertip to select from a menu of choices. These screens are used in computers and devices like photocopier machines. Joystick and game controllers are 2 popular input devices used to play games. Joystick allows the player to fly, run, fire or drive a character. The most commonly used point-and-draw input device is mouse. You can select menus, buttons, draw graphics, drag and drop items by using mouse. This figure shows different shapes of mouse: a 2-button mouse, 3-button mouse, and a mouse with a trackball. Mouse generates left click, right click, double click, and drag events. When you want to select an item, you can point to that item and click left mouse button. You can double click the left mouse button to open an application. If you click right mouse button once, it opens a shortcut menu. You can select an item and by holding the left mouse button, drag that item to a new location.
Optical devices include barcode readers and optical character readers. These use light as a source of input. Barcode reader reads the barcode and converts it into a computer-readable format. It converts the individual bar patterns into numeric digits. The image scanner converts printed text and graphics into electronic form. It works by sensing the intensity of light reflected at different points of the printed material. Color scanners use color filters to separate RGB colors. Modem scanners allow you to scan printed material and translate its image into editable text by using optical character recognition software. Although the conversion from image to text is quite complex task, OCR software has become very advanced and can translate the various fonts. All modern computers have multimedia capabilities. Input devices are used to make audio and video input. Audio input devices can be used to record voice to the computer. Modem computers have the ability to recognize the voice patterns. Multimedia capabilities allow you to conduct online education by using video conferencing and audio-video chatting. The digital camera works like a PC video camera, but it is portable. It enables you to capture images and save time to acquire images by traditional methods. Diskette or memory card is used to store the images. Modem digital cameras can be attached to the computer by the USB port.
The output devices are used to return processed data to the user. Commonly used output devices include monitors, printers, plotters, and multimedia speakers. These are discussed in this learning session. The most commonly used output device is monitor. Its output is in the form of soft copy. The two basic types of monitors are CRT monitors and flat panel monitors. CRT monitors are widely used with desktop computers. The screen of a CRT monitor is coated with phosphors, that is the grey material. The smallest number of phosphor dots is called a pixel. An electron gun is used at the back of monitor to fire electrons on each pixel through a coil. Metal plates are used to reflect the electrons on different parts of screen in a particular order. The phosphor particles glow when an electron hits them and an image is created. In color monitors, there are 3 electron guns that emit 3 basic RGB colors. Each pixel in color monitors contains 3 phosphors that are red, green, and blue. These are arranged in a triangular form. A shadow mask is used to hit the correct phosphor dot to create an image. CRT monitors are categorized depending on the way they display colors. Color monitors support from only 16 to 16 million colors.
Flat panel monitors are popular because of their small size. These are commonly used with notebooks, laptops, and now with desktop computers. The most common flat panel monitor is liquid crystal display. It creates an image by using special liquid crystal. The crystal becomes opaque when it is charged with electricity. The picture quality of LCD monitors is not quite good as compared to CRT monitors. Graphic adapter improves motion graphics quality. These are installed on motherboards on PCI or AGP slots. VGA boards used with PCI slots produce better quality, high-resolution graphics. Accelerated graphic port allows video data transfer. AGP has many advantages over PCI. AGP has its own data bus for transferring data, and it can pipeline commands like CPU. In addition, AGP can handle 3D graphics and supports video adapters with built-in video RAM. It also shares random access memory for better performance.
Size of monitor is another feature. CRT monitors are larger and require more space than a flat panel monitor. Monitors come in various sizes ranging from 5 inches to 30 inches. 14 and 15-inch monitors were popular in the past few years. Now 17 and 19-inch monitors are becoming more popular. Resolution is measured in terms of number of horizontal pixels times number of vertical pixels. Higher resolution monitors display clear images. Some common resolutions are 800 by 600, 1024 by 768 and 1600 by 1200. All these resolutions are in 4:3. It is called aspect ratio, and monitors are designed according to this ratio. Computer-aided designing involves millions of colors, and modern monitors support 16 million colors and higher. Another characteristic of monitors is its refresh rate. It is the rate at which the screen is repainted in 1 second. Usually, refresh rate is from 50 to 100 times per second. Higher refresh rate reduces screen flickering. Interlaced and non-interlaced monitors also affect monitor flickering. Interlaced monitors paint alternate line, while non-interlaced monitors paint whole screen in one pass.
The output of printer is in the form of hard copy. You can print a report, a picture, or a work plan. The common considerations for printers are cost, speed, text and graphics quality, maintenance, add-on features, and even noise. Broadly, printers are categorized into two types. These are impact printers and non-impact printers. Impact printers include dot matrix printers, daisy wheel printers, line printers, and plotters. Dot matrix printer prints with a head that contains 9 to 24 pins. Dot matrix printers are low cost. These have lower speed in the range of 40 to 200 characters per second, and these produce poor quality text and graphics output. These can produce carbon copy of output. These make noise and produce near letter quality output. Daisy wheel printers use a daisy wheel to produce characters and numbers. The output quality is better than dot matrix printers. These are not used commonly these days. These produce letter quality output. Line printers print a line at a time. These are faster than the dot matrix and daisy wheel printers. The speed of a line printer is measured in terms of lines per minute. The operation of inkjet and bubble jet printers is like impact printers. These use ink droppers to spray combination of ink to produce a colorful output. These have higher printing cost than laser printers. The speed of printing is quite slow in the range of 1 to 3 pages per minute.
Laser printers are non-impact printers. These use light and laser technologies to print pages. The black and white laser printers are low cost, while color laser printers are high cost. These print up to 30 pages per minute. Laser printers are capable of printing 300, 1200 and 2000 dots per inch. These produce high quality graphics output. All-in-one multi-function devices allow you to scan, copy, fax and print office documents. The output of architectural work is usually very large and may be printed over a few square feet paper. In this case, plotters are used. The two types of plotters are drum plotters and flatbed plotters. Drum plotters use pens and drums to print the image in continuous form, for example, an earthquake pattern. In flatbed plotters, the pens and paper move concurrently to produce the output. Business people use manual projectors or multimedia projectors to make presentations. The presentation graphics can be printed on transparencies in case of manual projectors. These graphics can be prepared by using presentation software like Microsoft PowerPoint. The computer can then be attached to the multimedia projector to make the presentation.
Terminals are used for both input and output from a remote computer. These include dumb terminals, intelligent terminals, and special function terminals. Dumb terminals have no processing capability. These comprise of an input device and output device, usually a keyboard and a monitor. These are attached to a remote computer. These work in simple text mode. Unix-based systems support the dumb terminals. These are installed in airline reservation offices, hospitals, and defense organizations. Intelligent terminals have processing and storage capabilities. These can interact with text and graphics applications. Special function terminals include autoteller machines and point-of-sale terminals. Autoteller machines facilitate you to make banking transactions across the network. These machines have a card reader area, a small printing device, a keypad, a display screen, and a voice area. The idea of ATM is now implemented in various other areas like airline reservation, attendance systems, in factories and colleges. Points of sale terminals are used in large departmental stores, restaurants, and at other locations. These have a keypad, a printing area, a small screen, and a storage facility to store the code, name, and price of the items. These print correct prices.
In this unit, we will introduce you to software and its types, Windows operating system, Windows desktop, Windows help, types of Windows, elements of an application window, working with menus, understanding folders, and copying, moving, and deleting files.
After completing this unit, you must be able to understand different types of computer languages, system software, and application software, work in Windows environment, use help to search different topics, understand different types of windows, identify elements of an application window, use menus, create, copy, move, and delete files and folders.
Instructions are given to the computer to perform different tasks. Collectively, these instructions are called a computer program. Examples of computer programs are a copy program to copy files and a program to create folders. Set of similar programs is called software. Depending upon their use and features, softwares are categorized into computer languages, system software, and application software. Computer languages are used to write computer programs. These can be categorized into low-level languages, high-level languages, and natural languages. Low-level languages are further classified into machine languages and assembly languages. High-level languages are another type of computer languages. These use English-like statements to write instructions. Some high-level languages include BASIC, C language, Lisp, and Java. Another type of computer languages is object-oriented languages. Popular object-oriented languages include C++, Java, Visual C++, and .NET languages. Fourth-generation languages are another type of computer languages. Visual languages are another most popular type of languages. Another category of computer languages is natural languages. Computer languages are further discussed in the next unit.
The second type of software is system software. Broadly, system software provides two types of functions, that are control functions and service functions. The control function manages the hardware resources of the computer. The service function provides a wide range of common services to the end user. These include file management, storage management, automatic program loading, plug and play feature, and communications. In addition, system software include translators, compilers, and device drivers. The last category of software is application software. These include application packages and customized application programs. Application packages include word processors, multimedia development programs, and communication programs. Customized applications may include air reservation system, accounting system, and inventory control system.
Windows is a state-of-the-art point-and-click operating system. It provides graphical user interface that represents files, folders, programs, and other services as icons. Microsoft introduced different versions of Windows. The operating systems for desktop computers include a series of operating systems. These are Windows 95, Windows 98, Windows Millennium Edition, and Windows XP. Operating systems for server computers include Windows NT, Windows 2000 Server, Windows 2000 Advanced Server. Some common features of Windows operating systems are support for large memory to execute complex software, multitasking feature to work on more than one program at a time, communication support, support for plug-and-place devices, FAT32 that allows access up to 2 terabytes of hard disk space, and a range of other features. The server family of Windows operating systems has additional features like user and resource management, strong security features, web server support, NTFS file system, and other range of features. To learn basic concepts of Windows, we will use Windows 2000 Professional Operating System. The environment of Windows 2000 Professional has similar look and feel as other Windows operating systems. The basic concepts are applicable to all graphical user environments with few variations.
Now, let us start to learn about Windows environment. The main screen in Windows is referred to as desktop. It contains some icons. Icons are pictorial representation of programs, documents, and other Windows applications. You can point to an icon and click left mouse button to select it or double-click on it to execute it. When an icon is opened, it is placed in an application window. Typical Windows icons include My Computer, My Documents, Network Neighborhood, and Recycle Bin. My Computer application is used to view, access, and manage hard disks, floppy diskette, files, and folders. My Documents folder contains most often used documents. Network Neighborhood is used to access resources across the network. Recycle Bin stores recently deleted files. These are available until you empty the recycle bin. You can open it and restore the selected files. In addition to these application icons, different icons are used for each type of file, folder, and application. This figure shows some icons for different types of files and folders. It has a Notepad file icon, MS Word file icon, MS Excel file icon, and a Help file icon. Taskbar is across the bottom of the screen. It allows you to quickly access programs, documents, and currently running applications. The taskbar contains a Start menu, icons for different applications that are currently executing, and System tray. When you click on the Start button, a pop-up menu is opened. It contains different applications and utilities. Most commonly used menu items are Programs, Documents, Settings, Help, and Shutdown. The arrow beside the menu item represents that a submenu is available. You can click on Programs group item to access the available programs like Microsoft Word and Excel. You can select Documents menu item to view a list of most recently created or used documents. Settings menu item has a submenu that allows you to access Control Panel from where you can add or remove new programs, install new fonts, or change your regional settings. It also provides access to Printer folder. You can install new printer or view the existing printers. In the taskbar, click on any icon that represents an application like MS Word or MS Notepad to make it active. The System tray contains volume control, system clock, or any additional software.
Windows provides an extensive help feature that provides detailed information about various topics. Click Start button and click the Help menu to launch Windows Help. The Help window has two frames. The left frame contains 4 tabs. These are Contents, Index, Search, and Favorites. Contents tab contains a list of help categories and topics. A closed book icon represents a category. When you move mouse pointer on any category or topic, it changes to a hand shape. The categories and topics act as hyperlinks. You can click on any category to expand it or click on a topic to display help page in the right frame. Some terms are underlined in the help topics. These are glossary items, links, and related topics. You can point to a glossary item and click mouse button to display a box containing information about that item. Blue underlined text is a link to a separate page. When you click it, it will open that page in the right frame. You can click on the Related Topics button to access topics that are related to the current topic. The second tab is Index tab. It displays an alphabetical listing of help topics. You can scroll through this list or type few starting characters to access any help topic. Select the required topic and click on the Display button. In addition to menus, Windows-based applications use dialog boxes to collect the information required to carry out your commands. Dialog boxes contain text boxes, command buttons, check boxes, radio buttons, and other GUI components. This dialog box shows common components. A text box is used to enter data. The rectangular buttons are referred to as command buttons. The OK button executes the dialog box and Cancel button cancels the dialog box. List boxes contain lists of files, fonts, colors, or other options. You can choose one item from the list. Radio buttons are small hollow circles that are usually grouped together to provide a selection of options. The dark circle within a radio button indicates that the button is selected. Only one of these options can be selected at a time. Some options have ellipses beside them. These indicate that an additional dialog box is available under this option. A double chevron indicates the dialog box can be expanded. The hollow rectangles are known as checkboxes. These boxes are blank or have a check mark to indicate whether the action should or should not be carried out. The action that is marked is carried out. More than one of these boxes may contain a check mark. To select an option, simply click on it. To deselect it, click a second time. You can use keyboard to select options in a dialog box. Use Tab key to move through the options in a dialog box. A mark key appears around the current selection. When you are within your desired selection, you can select it or specify some value. Use Tab key and select OK button and press Enter key to execute the dialog box, or select Cancel button and press Enter key to close the dialog box without execution.
Now we will discuss elements of an application window. We will use MS Word for this purpose. To start MS Word, you can double-click MS Word shortcut available on the desktop. Or go to Start menu, select Programs and select Microsoft Word to start Word. You can also execute Run from the Start menu. Type WinWord and select OK button to start Word. When Word starts, it displays a blank, untitled document. All Windows-based programs include similar elements. These are shown in this figure. At the top of the Word application window is Title bar. It displays Word icon, name of the application that is Microsoft Word, and current document name. The small icon is used to access a pull-down menu to restore, move, resize, minimize, or close the application. Title bar also contains 3 buttons to minimize, maximize, restore, and close the application window. The second line is referred to as the menu bar. It contains menus that contain all commands required to operate this application. You can point to a menu item and click left mouse button to access it. If you carefully look at each menu option, it has one underlined letter. These are called shortcut letters. These are also available on dialog boxes. You can access a menu by pressing and holding Alt key and pressing the underlined character. The standard toolbar can be used to quickly perform different functions. If you move mouse pointer to a tool without clicking it, a brief description of the tool will appear. The format bar is combined with the toolbar. Because these two toolbars are combined, you cannot see all of the icons. Word automatically displays the most commonly used tools on these two bars and offers a button to access the hidden tools. The ruler indicates the current margins and tab settings. The work area is the large interior section of the window that the program uses to display text, images, and tables. In Word, the work area is referred to as the text area. When the mouse pointer is in text area, the shape of pointer is like I-beam. You can click at that position and start typing. When the mouse pointer is over ruler, its shape changes to an arrow. You can double-click to open Page Setup dialog box. Scroll bar is used to scroll vertically or horizontally. The view icons are used to change the view of current page. The status bar is located at the bottom of the window. It has indicator for current page, section, and other related information. Office Assistant provides help on any topic.
The menus in Word function like menus in other Windows applications. Each menu contains a set of commands. You can open the menu and then select the desired command from the pull-down menu. You can point to the menu you wish to access and click the left mouse button once. When the menu drops down, move the pointer to the desired command and click the left mouse button again to execute the command. If you intend to cancel a menu, move the mouse away from the menu within the text area and click the left mouse button once. You can also access the menu system through the keyboard. Press Alt key once to access the menu bar. Type the underlined character of the desired menu option, for example F, to access File menu. When the selected pull-down menu appears, type the underlined character to execute the desired command, for example S, to save current document. You can press Escape key to cancel the current drop-down menu.
You should shut down your system before turning off the computer. Operating system updates and closes any files that were in use. Select Shutdown from the Start menu. A dialog box appears that shows different options. You can log off to close your current session. You can select Shutdown option to save Windows settings and any unsaved data to the hard disk. It then turns off your computer automatically or prompts you to switch off the power. You can select Restart to save Windows settings and any unsaved data to the hard disk. It then restarts the computer. You can select Standby option to place your computer on standby mode. That means your computer will not be turned off completely. After selecting an option, select OK to proceed or click Cancel to return to Windows.
Yellow boxes in Windows environment represent folders. These store related files, applications, and other subfolders. My Documents is a special folder on the desktop. It holds recently used or created files and folders. Open My Computer to show contents of your computer. Double-click on C drive to see different folders on your hard disk. Some of the important folders include Windows, program files, and temp folders. In addition to these folders, you can create your own folders on this drive. For example, you can create a folder to store your assignments for course code 3422. Select File menu, select New, and select Folder. This will create a new folder and name it New Folder. You can change the name of the folder to 3422. The name of folder can be from 1 character to 255 characters, and it can also contain spaces. You cannot use /, a less than sign, a pipe symbol. If you used any symbol that is not allowed for the folder names in Windows, it will display an error dialog. You can then rename the folder.
Now we will create a file and then learn to copy it. Double-click on the 3422 folder, select File menu and select New. Then select Text Document. A notepad file will be created. Type First Assignment as its name and press the Enter key. The file name has two parts, that is file name and its extension. By default, the extension of the file is not visible in the Explorer window. Windows provides file extension automatically for files of all installed application programs. You need not to specify the extension. To copy the selected file, select Edit menu and select Copy. To make a duplicate copy of this file, you can select Edit menu and Paste command. The copy of this file will be saved in the same folder with a new name. This is because the file names in the same folder cannot be the same. You can copy this file to desktop by using right mouse button and selecting Paste command. You can use right-click on the file to open a pop-up menu. Select Send to command and select Floppy drive to make a copy on floppy diskette.
To delete a file or folder, you can select the file or folder and press Delete key. This will show you a confirmation dialog box before sending the file to Recycle bin folder on the desktop. If you accidentally deleted a file, you can restore it from the Recycle bin. It will be restored in the folder from where it was deleted. If you deleted a file from Recycle bin, you won't be able to restore it. Sometimes you need to move a file or files from one location to another location. To move copy of first assignment, select it, click on the Edit menu and select Cut command. The icon for the file becomes dim. Right-click on the desktop window and select Paste to physically move the file from 3422 folder to desktop. In this unit, we will introduce you to programming languages and their features, simple program construction, main components of a program, Turbo C integrated development environment, and writing programs in C language.
After completing this unit, you must be able to use suitable programming language to write programs, construct a simple program, identify main components of a program, use Turbo C integrated environment to write, save, compile, and execute programs.
We have already discussed programming languages and their types in Unit 5. Now we will discuss some features of each programming language. The lowest level of computer language is the machine language. The instructions of machine language comprise of zeros, ones, or sequence of zeros and ones. The instructions written in machine language do not require a translator or a compiler to convert codes, and their processing is fast. The difficulties in using machine languages are memorizing codes and memory addresses, finding errors in programs, and their machine-dependent nature. The next level of computer languages is high-level languages. The purpose of these languages was to enable programmers to write code in their native language like English. Translators and compilers are required to translate programs written in high-level languages into machine language. These allow you to divide a program into small reusable routines called functions or procedures. Some high-level languages include Fortran, COBOL, BASIC, Pascal, C language, Prolog, RPG, Lisp, and Java.
Fourth-generation languages allow end users to extract information from a data source. The user only specifies the output and the code is automatically generated by the language application software. Modern database applications come with query generators to produce output by automatically writing the queries.
Visual programming replaces text-based instructions with the graphical components that include buttons, combo boxes, and rectangles. Integrated development environments enable programmers to write complex software easily. Program debugging is simpler. Visual development environments include Visual Basic Integrated Development Environment and Boolean Turbo C Integrated Development Environment. Natural languages enable computer to accept instructions in the form of natural languages like English. At present, computers can accept and recognize different languages.
A computer is a general-purpose machine that can solve an infinite variety of problems. However, the problem-solving capability of a computer is entirely dependent on the human ability to develop efficient algorithms. An algorithm represents logical steps to solve a problem. Computer program development involves a series of activities. Broadly, these activities include problem analysis, logic design, pseudocode design, coding, debugging, testing, and implementation. Problem analysis involves understanding the problem. A simple problem can be addition of two numbers. Logic design aims at developing the algorithm to solve the problem. The problem can be divided into small modules that perform independent functions. For example, a typical problem may be divided into separate modules to get input, validate data, make computations, and generate output. The modular approach is also called structured programming. The programming logic is symbolically represented by flowcharts. The flowchart shows the sequence of steps to solve the problem. It shows symbols to represent the start of program, initialization of variables for input and result, addition process, and output. Pseudocode expresses the programming steps in ordinary language. Plain English sentences are used to express input, output statements. For example, start the addition program. Create memory locations called variables to hold two numbers. Create a variable to hold the result. Get input from user. Perform addition and print the result. Coding involves translation of pseudocode into a computer language. It may look like this in C language. The program may contain some errors or bugs, and the process of identifying and removing the bugs is called debugging. Two types of errors are syntax errors and logical errors. Syntax errors occur due to violation of grammatical rules of the computer languages. The computer lists these errors during program compilation or translation. Logical errors represent errors in logic that solves the problem. Logical errors are difficult to point out by the machine. To check any inconsistency, the program is repeatedly tested with different set of data. If the output is incorrect, the logical steps are revised. When the program is error-free, it is ready for implementation.
Computer programs differ in size, scope, complexity, and their application. Regardless of their function, these comprise of these components: declaration statements, input and output statements, arithmetic statements, logical operations, control statements, repetition control structures, and reusable subroutines. Declaration statements are used to declare variables and constants. Computer languages provide special words for declaration statements. These are called keywords and have specific meaning for the compiler software. For example, C language provides int keyword to declare integer variables that can hold whole numbers. The declaration statement may look like this: int keyword followed by the name of variable terminated by a semicolon. Input statements are used to enter data during computer program execution. It identifies the source of input and the memory location where the input is saved. Languages use words like get, input, and scan to receive input. For example, C language uses scanf statement to get the input using keyboard. A typical input statement in C language may look like this. We will discuss these statements when we learn to write a program. Output statements transfer the results of operations to output devices. Languages use verbs like print and display for this purpose. For example, C language uses printf statement to display the output on monitor. A typical output statement may look like this. Arithmetic operations include multiplication, division, addition, and subtraction. Computer languages use mathematical symbols for arithmetic operations. These C statements declare a variable to hold the result of addition. The result is then stored in the variable sum. Logical statements are used to compare numeric and non-numeric values. Logical operations include to test whether a value is equal to, less than, or greater than another value. These statements compare two numbers. The expression evaluates to true because 5 is greater than 2. Control statements allow you to execute a set of statements based on a logical decision. Computer languages provide if structure, if-then-else structure, nested if structures, and case structures for this purpose. You can use logical expressions in control statements. For example, the expression A is greater than B can be used in control statements like this. In addition, languages also provide repetition control structures that include while, do-while, and for structures. These will be discussed in another course. Modern programming languages also allow dividing programs into small routines called functions and procedures. These perform specific tasks. Functions are reusable program components.
So far, we have learnt the technique of basic program construction and components of a computer program. Now, we will learn to write some programs in C language. We will use Turbo C Integrated Development Environment to write and execute our programs. Turbo C version 3 is a DOS-based application. When you execute Turbo C, the main screen may look like this. It is placed inside a window. You can press Alt, Enter key to maximize it. In Windows environment, you won't be able to use mouse, and we will use keyboard shortcut keys for different actions. To create a new C program, choose File menu, select New, and press Enter to create a new file. The name of file will be provided by the application automatically. Before writing a program, it is important to specify the file locations. These locations will be used during program compilation. If some required file is not found in the specified locations, an error message is displayed. To specify the directories, select Options, choose the Directories menu. Here, 4 input boxes are provided. The first box specifies the folder where the files required during program linking and compilation are stored. The second box specifies the folder where the required libraries are available. Libraries are files that contain different functions. These are used during program construction. The Output Directories box specifies the location where the object file, backup files, and executable files will be stored. Here we specify the folder where we want to save our files. For example, C folder on D hard drive. Source directory specifies the location for additional libraries. Here, we specify the C folder on D drive. Select OK by using Tab key and press Enter. Now, we are ready to write our first program.
Now we will discuss the construction of this program. The first line of my first program starts with the void word. Void is a keyword. It has special meaning for C compiler. It is followed by a main function followed by empty parentheses. These parentheses represent the main is a function. Every C program must contain main function. The curly braces at second and third line represent the block of main function. it may contain many C statements. Alt F9 key is used to compile the program in this environment. You can also select Compile menu. Select Compile and press Enter key to compile your program. A small window appears that shows compilation information. Success message is shown if the program successfully compiles. Note that total number of lines that are compiled is 3. Press any key to continue.
The next program prints a welcome message. It contains a C statement that prints the message. Printf is a function because it is followed by a set of parentheses. These parentheses enclose a message inside double quotes. A function may or may not take arguments. In this program, main function does not take an argument, while printf function takes an argument. If you compile this program, it will generate an error message that is function printf should have a prototype. The prototypes or definitions of built-in functions are defined in a library file that is available in the include folder that you specified earlier. To include the library that contains prototype of printf function, you must use include directive before the main function. It starts with a number sign followed by include directive followed by a file name enclosed in double quotes. The file stdio.h contains prototypes of commonly used input-output functions. It contains the definition of printf function. When you compile this program, it shows compilation of 312 lines. But the actual code has only 5 lines. This is because the compiler includes additional lines for compilation. Include directive includes lines of code from stdio.h for compilation. Compiler also adds some other information that is required to compile and execute this program.
In this unit, we will introduce you to basic concepts and features of MS Word, advanced features of MS Word, creating new document, saving a document, editing text, selecting a word, a line, or text using mouse, deleting and undeleting text, redo command, formatting Word document, print preview and printing, and working with multiple documents.
After completing this unit, you must be able to use Microsoft Word to create and save documents, edit text, format Word document, use print preview, page setup and print documents, work with multiple documents.
Microsoft Word is the most commonly used word processor. It provides easy-to-use interface for writing a large variety of documents. You can write a small memo or a complete book using MS Word. Word 2000 provides many features. These include some basic features and advanced features. Basic features include creating files, using existing files in different formats, printing documents, using bullets and numbering, inserting date and time, inserting images, formatting text, creating tables, sorting tables, automatic spell checking, and using thesaurus and grammar. Advanced features of MS Word include creating different types of documents and even web pages, using templates to create documents, inserting nested tables, sharing information across the network, integrate objects of other applications in Word documents, send fax by using MS Word, use mail merge features, and add graphics and apply themes. Some of the basic features will be discussed in this learning session.
When Word starts, it places you in a new document. You may immediately begin typing your file. You can also use File menu to create a new document based on built-in templates in Word. Click File menu and select New. Word presents you with the new dialog. You can create blank document, legal documents, letters, faxes, memos, professional CVs, publications, reports, and even web pages. When you select a template, Word presents its preview in the preview window. Select OK to create a document based on the selected template. It is important to note that your changes do not affect the original template. If you want to make a new template, you may select the Template Radio button.
When you have completed typing documents, you can save the document with a name that will allow you to easily find it again. There are two options in the file menu that are Save and Save As. When you select Save options first time, it displays Save dialog box. The dialog box allows you to enter the name of file, select the save type and location where the file will be saved. By default, the name of document is Doc1. Its type is Word document and location is My Documents. You can use letters, numbers and spaces in a file name. The length of file name can be from 1 to 255 characters. Press Save button to save the file. You may continue adding more text to this file. When you select Save option from File menu, again, it will simply update the contents of this document. Ctrl+S key combination and Save button on the toolbar allows you to save the current document. Save As option saves an existing file with the new name or as a different format to be used by other programs. In the Save dialog box, click on the down arrow beside the box labeled Save As Type and select the format from the list provided. The Save dialog box displays the Places bar that includes the History, My Documents, Desktop, and Favorites. You can access any of these storage locations. You can select a new storage location by clicking the down arrow beside the box labeled Save In. Some buttons are provided at the top of Save dialog box. You can use the button with the left arrow to display previously visited folders. Use one level up button to move up one folder. Use Web button to search on the web. Delete button to delete a file, or use Create New Folder button to create a new folder. Click on the Views button to arrange the icons by name, type, size, or date. Use down arrow button beside the Tools button to access a pull-down menu for advanced saving options such as mapping network drives and customizing the web options. When you have completed entries of Save dialog box, click on Save button to save the document.
Before learning the editing in MS Word, you must be familiar with the navigation across different parts of the document. This table shows arrow keys and control keys and their purpose. If you use the Shift key, With the movement keys, you can select Text. After you have typed some text in MS Word, you may want to edit it. This involves deleting text, inserting text, replacing the existing text, or moving the text. To delete text, character by character, you can use Delete and Backspace keys. The Delete key deletes the following text, while the Backspace key deletes the character that was immediately typed.
Text formatting involves many operations to change the appearance of text. Some formatting operations include applying attributes like bold and italic, changing the font, size, and color of text, aligning text, adding bullets and numbers, presenting text in tables, applying indentation, and changing line spacing of text. Word provides Format menu on the toolbar to apply different formats. It also provides a Format toolbar that contains different buttons for various formatting options. You can select a style for your text by clicking on the down arrow beside the Style tool. Select a text and apply bold, italic, or underline attribute from toolbar. Select a text and apply different font from the toolbar. The alignment of current paragraph changes as you click on left align, center align, or right align button on the formatting toolbar. By default, this alignment applies to the current paragraph where your cursor is blinking. You can select multiple paragraphs to apply alignment. You can use Justify button to equally align the text on both sides of the page. You can increase or decrease the indent of current paragraph by using indent buttons. Use Numbering or Bullets button to apply numbering or bullets to your text. Word automatically creates new line number or bullet as you press Enter key at the end of the numbered or bulleted line. If you want to highlight some selected text with a different color, you can use Highlight button. There is another button to change the color of text. Dialog boxes for these options are also available from Format menu in the menu bar. You can access many other options on these dialog boxes. For example, Font dialog box has many other options like strike through, superscript, subscript, and much more. You can access Paragraph dialog box in the Format menu. It allows you to specify alignment, indentation, and line spacing. Table menu allows you to insert table in your document. You can then type text inside the table. You can change the appearance of borders of a table by using Outside Borders button on the formatting toolbar. It has different options to apply and remove borders. In addition, Table menu allows you to draw table, insert table, select rows or columns, and adjust the size of table. It also allows you to enter mathematical formula and sort the entries of the table.
Word automatically checks the spellings as you type. It underlines the misspelled words with a red line. This underlining is for viewing purpose only. You can point to the red underlined word and click the right mouse button to access menu that offers the correct spelling for that word. It also provides other features. Ignore All allows you to ignore the spelling of this word in the whole document and keep it as it is. Add feature allows you to add this word in the custom dictionary. Autocorrect feature gives you autocorrect options for the misspelled word. It will automatically update the autocorrect entry for this word, and whenever you misspell it, Word will automatically correct it. The dialog box shows the misspelled words with sentences in the top section. It also shows grammatical errors. It shows the suggestions in the suggestions section. You can select appropriate suggestion and click Change button to correct the error in your document. Dialog box shows the next incorrect sentence in the top section and suggestions in the suggestions section. You can select appropriate suggestion and click Change to move to the next incorrect sentence or word in your document. If you want to ignore the suggestions and keep the word or sentence as it is, you can click Ignore to ignore once or Ignore all to ignore all occurrences of this word or sentence in your document. Sometimes the word is not found in the main dictionary and MS Word assumes it a spelling mistake. To avoid this, you can add a particular word in the custom dictionary. For example, the word allama is not found in the main dictionary. You can add it in the custom dictionary. Change all option changes all occurrences of a word in the whole document. Undo last reverses the last action made during the spell checking. Before printing a document, you may want to see how the printout will look like, where the text, header, footer, and footnotes will be printed on the page. You can click on Print Preview button in the toolbar or select Print Preview from the File menu to preview the current document. When you are in the Print Preview mode, the text window shows a preview of your document, as it will appear when printed. The toolbar has now changed. The window displays a non-editable page. The mouse pointer changes to zoom control. The magnify tool is used to magnify or demagnify the document. If this button is turned off, you can edit the text in preview mode. You can control the zoom factor during page preview. The print button starts printing the current document on the default printer. Single page button displays a single page during the preview. Multiple page button displays multiple pages during the preview. Ruler button shows or hides the ruler. The horizontal and vertical rulers allow you to set the margins of the page. Sometimes a small amount of text is on the last page. You can use Shrink to Fit button. Word will try to fit the output on one page. Use Full Screen button to hide all screen elements and show the text only. Press Escape to show elements again. Close button closes the print preview and returns to the editing screen. When working with two or more open documents, you can switch to the desired document by using Window menu, or you can quickly switch to any open document by clicking on its icon in the Windows taskbar. Each time you create a new document or open an existing one, Word displays it along the taskbar. Simply click on the document you wish to switch to, and that file will become active.
In this unit, we will introduce you to Microsoft Excel, basic features of MS Excel, creating and saving a workbook, editing worksheet, using mathematical formula, format worksheet, print worksheet, and workbook. Work on workbook.
After completing this unit, you must be able to work in Microsoft Excel application, use basic features of MS Excel, create and save a workbook, edit worksheet contents, perform mathematical calculations, apply formatting to worksheet contents, print worksheet and workbook.
When you are working with numerical data like a profit and loss statement, a budget plan, or a sales forecast, you need a spreadsheet application that can manipulate such data. Microsoft Excel helps you to organize and analyze these data. The main feature of Excel includes work on many worksheets, allows you to undo last 16 options. Drag and drop facility allows you to move text, images, and other components across workbook. Up to 32,000 characters in a single cell. Drawing toolbar allows you to draw different objects, auto shapes, lines, and boxes. You can also insert images by using Clip Art Gallery. You can use mathematical functions to make calculations. MS Excel provides you a large number of financial, mathematical, and statistical functions. Autocomplete feature allows you to type conveniently. Autofill feature allows you to automatically fill series of data. Chart wizard allows you to represent data graphically.
When you start MS Excel, the application starts in a window. The title bar shows an icon name of application and name of workbook. Menu bar contains file, edit, and other menus. Toolbar contains buttons for new, open, save, and other commands. Formatting bar allows you to change the appearance of worksheet entries. Drawing toolbar allows you to draw shapes and other objects. The work area that contains rectangular boxes is called worksheet. These rectangular boxes are called cells. There are 3 worksheets in a workbook. The work area is a grid of rows and columns. These rows are numbered from 1 to 65,536 across the left of the worksheet. The columns are numbered from A to IV. These are 256 columns. Current box has a bold-face block around it. The reference of current box is shown in the name box. Formula bar shows the contents of the current cell. Status bar shows the current status and other indications.
Now we will create a new workbook in MS Excel. Select File menu and select New. A dialog box appears. You can create a general workbook or use a template to create a customized workbook. We select General Workbook at this stage. You can type in a selected cell. We have already typed Profit Statement in cell A1, March 2003 in cell A2, and other information as shown in this worksheet. Now we will learn to save this workbook. Select File menu and select Save or press Ctrl S key. The Save dialog box appears. By default, the name of workbook is Book 1. You can give a suitable name, for example, Profit Statement March 2003. Choose the location where this file must be saved. We have selected My Documents folder. Point to Save button and press left mouse button to save this file. Now we will learn to edit the worksheet. You can press F2 key to edit the current cell. You can also point to Formula bar and click mouse left button to edit the contents of current cell.
Now, we will use AutoSum feature to calculate total sales and expenses. Move to cell C9 and press AutoSum button on the toolbar. It automatically inserts a formula for you. It starts with an equal sign, sum word, left parenthesis, and a range of cells. The range is highlighted from cell C4 to cell C8, separated by a colon. The formula ends with a closing parenthesis. Press the Enter key. The sum of the specified range appears. To calculate total expenses, move mouse pointer to the right bottom corner of cell C9. It changes to a plus sign. Hold down left mouse button and drag the mouse pointer to cell D9. The formula is copied to D9. You can also use Copy command from Edit menu to copy cell C9 and paste it in cell D9. Note that the cell references automatically change to calculate total of expenses. Now we will calculate profit for each city. Go to cell E4. Here we will insert a mathematical formula manually. Press equal sign and type the cell address for Islamabad sales value, that is C4. Type minus symbol and then type cell address D4 that contains expenses for the Islamabad city. Press Enter. The profit will be calculated. Go to cell E5 and type equal sign C5 minus D5. Press Enter. The profit for Rawalpindi will be calculated. You can copy the formula and paste it in cell E6 and E7. It is important to note that cell references automatically change. Now we will learn to format the contents of worksheet. Hold left mouse button and select cells from A1 to F2. Select Format menu, select Cells. A dialog box appears. Select Alignment tab. Select Center Across Selection from Horizontal drop-down box. Press OK. The text in cell A1 and A2 is centered across selection. Go to cell C4 and press Comma Style button to change the appearance of sales amount. You can increase zeros after decimal point or decrease them. You can select multiple cell and apply this formatting. The worksheet may look like this after different formatting operations. Now, we will learn to print the worksheet. You can preview the document before printing. It gives the idea how the printout will look like. From the File menu, select Print. A dialog box appears. You can specify the printer, range of pages, print a selection, active sheet, or the entire workbook. When you have specified these parameters, click OK to start printing. After completing this unit, you must be able to define Internet and World Wide Web, browse popular websites, utilize Internet-based services, send and receive emails.
The Internet has revolutionized the computer and communications world like nothing before. The invention of telegraph, telephone, radio and computers set the stage for this unbelievable integration of capabilities. Internet is a worldwide broadcasting capability. Internet, sometimes called the net, is a collection of hundreds of millions of computers that are connected worldwide by using telephone lines, fiber optics, VSATs, satellites, and a number of devices. All these computers communicate with each other and share information irrespective of geographic location at any time and free of cost.
Internet provides a large number of services free of cost and irrespective of geographical location. Some basic services include electronic mail, chatting and audio voice conferencing, file transfer, search facility, educational resources, digital libraries, discussion forums, downloadable software, entertainment and many other services. The most commonly used feature is electronic mail. The most popular website that provide email services and free mail storage are Hotmail and Yahoo. There are also many other websites that provide email facility as a part of their main site. To send and receive an email, you need to create your own mail account. We will learn this later in this session. In addition to email, Internet provides other communication facilities like discussion forums, news groups, mobile messaging services, and much more. Besides simple text-based communications, you can use Internet for audio-video conferencing. Chatting software like MSN Messenger and Yahoo Messenger provide video chatting free of cost to the registered users. You can transfer files over the Internet by using File Transfer Protocol. File Transfer Protocol ensures data integrity irrespective of distance between computers. Software packages are available to connect to a remote computer and copy files to or from that computer. You can use Internet to search web resources including websites, images, addresses of organizations, and whatever you want. You can search by using popular search engines. These provide you with the available information across the net. Internet is a great source for educationists and students. You can access online tutorials, reading materials, and any up-to-date information on the web. You can download these resources from the net. You can send your problems to Microsoft, Sun, Macromedia, or IBM. These provide online support for their products. In addition, there are discussion forums where programmers can share their expertise. Some websites provide digital libraries on payment. You can entertain yourself by listening to your favorite music online. In addition, you can play live games, check latest cricket score, or download your favorite music. If you have an email account, you can log on to access email services. Access Yahoo web page by typing the address mail.yahoo.com in the address bar. Type your Yahoo ID and password. Click Sign Up button. If the username and password are correct, you can access your inbox to view mails. When you click on Inbox button, the received emails are displayed. You can select any mail and view it. You can use Compose button to compose an email that is to be sent to another recipient. Type in your message and the email address of the recipient to send the mail. If the mail is undelivered due to any reason, the mail server will send you the confirmation after some time.